create a new project, and I'm going to say next from command line, like from the template. Let me just create a lecture number 6, which is conditions and loops. Code, open, command finish. Pretty cool. Alright, bring it up over here. That looks good. So let's first look at the conditions part. Okay, the if conditions. What are conditions? Now, what is a condition? Okay, let's see. Why would we require such things? So basically, let's say you want to, in our previous example, that input a salary, and if the salary is greater than 10,000, give a bonus of 2,000. Otherwise, give a bonus of 1,000. So this check, if this is this, do this. Otherwise, do this. This is something we can do via if statements. The syntax looks something like this, but this is the way you can add multi-line comments. So just slash star star slash, everything you add in this will be a comment. So the thing that I'm trying to show you over here is what is the syntax? How do we write a if statement? Syntax of if statements. Okay, so this is the syntax. You write if brackets boolean expression, so either true or false. It should be like true or false. Okay, and then the body, whatever you want to do in it. Okay, so if this condition is true, do this, and then there's another condition called else, do this. Okay, for example, I can say something like int salary is equal to something like this. Then I can say if brackets, I need a true or false expression, a statement that will give me either true or false. So I can say if salary is greater than 10,000, so this will definitely give me true or false. Salary will either be greater than 10,000 or less than 10,000. This will give me either true or false. I can say salary is equal to salary plus 2,000 rupees. Otherwise, salary is equal to salary plus 1,000 rupees. And then in the end I can just say print the new salary. This one is definitely greater than 10,000, so it will be 26400 because salary, sorry, 27400 because it's greater than 10,000. It will do this. So in if and else condition, only one of these are going to run. Only one of these are going to run. You can put a debug pointer here, try to debug this program, and you can see line by line how these things are working. So right now we are here, salary is equal to this much. It's going to check, hey, is 25,400 greater than 10,000? It's going to say yes it is. Then it's going to go inside. Yes it is. It went inside this if condition, means it will not go inside this else condition. If and else, only one of these will execute. You can see this was not executed. New salary, input and exit out of the program. You can also add multiple else if statements in the same thing. So let's say you want to add something like multiple if else statements. So let's say you want to add something like if the salary is greater than 10,000, then salary is equal to salary plus 2,000. You can also write it as salary plus equal to 2,000. Okay, this is same as writing salary is equal to salary plus 2,000. Okay, shortcut form. Otherwise, if, so you can see else if means I'm combining more than one else if conditions. If salary is greater than 20,000, give a bonus of let's say 3,000 rupees. in the end I will have else condition only. Okay, in the end I will have else condition only. Okay, cool. So this else basically means if none of the above conditions are true, then execute this condition, else salary plus equal to 1000. Okay, that is a multiple if else statement. So these are conditional like conditions, and we can use the if else statements to structure the flow of our program. And now let's look into something else which is known as loops. So we'll be doing some nice questions in this session only, and that will make it much more clearer. We will actually be, let's say, creating a calculator app program, okay, in this session only. So that is going to be a very nice hands-on experience. So I'm going to say conditionals, file name conditionals, another file name I'm going to create loops. Alright, so we have scanner. I can say input is equal to new scanner. We already have seen all these things. Then I can say loop. Okay, so what is a loop? Okay, forget about scanner right now. Let's just do simple loop. So I can say something like what is a loop basically? So loop is basically, let's say the question is print numbers from 1 to 5. That's the question. You can do it something like this. 1, okay, 2, 3, 4, 5. Okay, otherwise if someone asks you, hey, print hello world 5 times, so you can do something like this. When to or body, like whatever you want to do, how many times you want to do it. Initialization, condition, and increment decrement. Okay, so for example, let's say the question is print numbers from 1 to 5. Okay, that is the question. Bracket number, tell this increments 1, 2, 3, 4, 5. Let's see how this is working then. What is values you take? When the number it will and it will 2 less than 5. Yes, it 5 will be 3. Be less than equal to n num plus plus. So, looking into and then body. That's it. That is it. Let's try to convert this program of 1 to 5 numbers into a while loop. So I can say int num is equal to 1. So basically I'm converting this program into a while loop, so that is why you will be able to see the reference, like how this is getting converted to a while loop. Basically the for loop we wrote before, we are converting it into a while loop. So I can say while, so basically the initialization part, I'll just copy paste this for reference. So for the initialization part, that will come outside the while loop. This condition will now come inside the while loop. This body will come inside the body of the while loop, and this increment thing will also come inside the body of the while. That's it. Let me try to hide this thing. Let's try to run this. Oh, it's actually asking for an input. Let me also hide that. This work. So here, okay, this is 6 program. Need taking input from a user till the user does not press X. Press and loop and the one to X hello world. And this is what happened. We'll check that again. If you want to run this loop, this condition should follow. While n is not equal to 1, it will say n is equal to 1, hence loop will end. Okay, so in case say public static void main. So one way we can do in b is equal to in dot. Let's try to solve some questions over here, because questions are important in order to understand how these things are working internally. So let's say we create a question like largest. So you will be giving 3 numbers, and let's say public static void main scanner input is equal to new scanner system dot in. So basically you are going to input 3 numbers. Okay, so I can say a, b and c. Int a is equal to in dot next int, int b is equal to in dot next int, int c is equal to in dot next int. 3 numbers are here. Question is, find the largest of the 3 numbers. How do we do that? So let's look at how we are going to solve this problem. You can also create a flowchart for it if you like, but imagine that you have 3 numbers. Let's say a is equal to 10, b is equal to 20, and c is equal to 30. And you have to figure out which is the largest number from all these 3 numbers. So one way we can do this, we can, let's say, assume that this is the largest number. Okay, we can take a maximum value. We can say maximum is equal to, let's say, 10. Then we are going to check this with B. Is B greater than maximum? That the current maximum that I have, is B greater than that? It's going to be like, yes it is. So in that case, it's just going to say that my maximum now is equal to B. Then it's going to make another check, if condition. If C is actually greater than my maximum, is 30 greater than my maximum, which is currently now 20? It's going to be like, yes it is. Then max is equal to 30, or C. Means 30. That is my answer. If you aren't able to see, here you can see. There we go. Cool. So let's try to code this example. So here in this case, I will say, let's say int maximum is equal to A. Then I can say if B is greater than maximum, I can say maximum is equal to B. Otherwise I can say if, let's say, C is greater than maximum, max is equal to C, and then our output say maximum. Let's give it 3 numbers, 10, 20, 30. 30 is the maximum one. Let's give it something else, 56, 12, 79. 79 is the maximum one. 33, 789, 65, 789 is the maximum one. That is what's happening. It's saying initially, let's say it will say, let's try to run this code only, debug it, and see how this thing is working. Input, cool. A is equal to 33, so it's saying max is equal to 33. Okay, currently max is equal to 33. Then it's checking, hey, is B greater than maximum value? It's going to be like, yes it is. Then the new maximum value is going to be B. Now the new maximum value is going to be 789. That is true. You can see maximum is now 789. It's not 33 anymore. Now it's checking again. Is C greater than the maximum value? Is 65 greater than the maximum value, which is 789? No, it's not. Hence, this will not execute. This if condition will be false. This will be false. So this will question that max is equal to C. Same thing. Here it's actually trying to suggest us, IntelliJ is saying you can optimize this loop. Yeah, you can use a maximum, the math.max call. That is also something you can do. So basically math, the math class has something like this. So if I comment this out, you can say my n. Okay, so this is going to contain the maximum value of these two, and I can again pass this in math.max for C. Okay, so this is basically saying, basically if I do math.max, let's say 34 and 57, so it's going to print 57. Let me comment this out. It will give an error because did not comment out this thing. Now it should run. 57. That is what math.max is doing. Okay, if I replace this with my variable max, take the inputs. Now let's try to run this. I give 3 numbers, 10, 30, 27, it will print 30. Why? Because it is first going to say math.max of 27 and whatever the maximum value is of 10 and 30. So it's going to be like math.max of 27, 30 means 30. That's my answer. Now let's go into the next question. Let's do something. Let's say we input a character, a letter, and basically an alphabet, and it will tell us whether the alphabet is uppercase or lowercase. Let's try to make that program. That would be pretty nice. So you can say type check or something like case check or whatever. Okay, case check. Let's start in void main, and here I can say scanner input is equal to new scanner system.in. Let's take a character input. There is no such thing as in.nextchar. So for that we're going to have to take a string input and take the first letter of it. Okay, so that's the way to do it. Characters, sorry, char ch is equal to in dot next dot trim dot char at 0. What am I doing over here? Trim basically means that I'll just hide this for now. Let's say I say print in dot next. This is just going to print the next word. So if I just run this, it's just going to print the next word. Okay, it will take the next word over here and it will print it in this function only. So I can say hello, so it will print hello, nothing new over here. What is dot trim? Dot trim basically means remove all the extra spaces that are at the end of these words. So I can say if I take next for let's say if I do trim over here. Now let's say if I print it. Let me do a space. Hello. So you can see extra space was removed. Okay, because that is not what we want. We basically want that, okay, we are going to be inputting a number like a character basically, not a number. So I can say I'm going to be inputting k. So this k is actually a string input. You cannot take like a char input. It will convert it into char when you use this method called char at 0. Don't worry about this right now because string is a separate module of this course. So we'll look into it later on, like what is char at and everything. But in short, if you want to understand, it's not that complicated. This is a string. Char at basically means give me the character at this index of the string. String, you can imagine it as a character array. Array is actually the next topic, so it will be much more clearer then. But in arrays, index starts from 0. So if I'm saying something like hello, okay, so if I'm saying, let's say string word is equal to something like hello, and then I print word dot char at 0. This is going to print which is the character at this word's 0th index. H, it will print H. H, which is the character at index number 2. So 0, 1, 2. L, it will print L. Okay, so this char at is actually returning a character type. You can see over here, character type. Okay, so if it is returning a character type, then we already have learnt about data, data type. data type, so I can store it in a character type. That's why it's working. Now I will input a character. character and it will be stored in the ch input, let's say L type character. Question is, you need to check whether this is lowercase or uppercase. So the ch and everything you can use like the ASCII values and stuff, but we can also do something like if, because since it's a character, I can directly compare it with the values of lowercase a and lowercase z, if it lies in the range of that, because in the type section we saw that it actually converts it into like checks when integers. So we already saw that. If you haven't, check out the link in the description below. We have an entire session on that, on types and everything and how these compare. This is greater than equal to a and ch is less than equal to z. Basically this is something we did not cover before. And so basically if you want to add two conditions, like both of these conditions need to be true, you can use the and operator. Okay, so it will only be true if this is true and this is true. Okay, if we go into our conditionals again, and if I just hide this thing, so you can see multiple. I can say if let's say int a is equal to 10 and int b is equal to 20. I can say if a is equal to 10 and b is equal to 20. So is a equal to 10? Yes it is. B equal to 20? Yes it is. It will print. If you say or, you can also add or. Or basically means either one of these should be true. So if I make this one false, so even though a is equal to 10, b is not equal to 20, it will still run because this is or, means any one of these to be true. We will do this in detail when we do bitwise operators. Okay, these are bitwise operators. We'll do it in detail. Hello world. Okay, we'll do it in detail. There's a separate section for this. And if I do something like okay, so you already learned about and or. There's double equal to, basically compares the value of this. And there's one more called not equal to. If a not equal to 35, print this. Is a equal to 35? No, it's not. So hence this is true. A should not be equal to 35. That is true. A is not equal to 35. A is 10. Hence it will print hello world. So you can multiply. You can add so many conditions you can add in just one single if condition. Okay, like we are adding 2 over here. If a is greater than a, the value, like if basically what is happening is adding the previous two numbers. Let's say they start. Cool. Let's move on to the next question. Now let's Now let's look into another problem, which is the Fibonacci problem. What are Fibonacci numbers? Fibonacci numbers are basically, let's say they start by 0 and 1, starts from 0 and 1, which is, let's say, the 0th Fibonacci number, first Fibonacci number, and the series then continues by adding the previous two numbers. So basically the next number is going to be what? Sum of the previous two numbers. 0 plus 1 2, 0 plus 1 is 1, 1 comes over here. The next number is going to be the sum of the previous two numbers. 1 plus 1 is 2, 2 will come over here. Next will be the sum of previous two numbers. 2 plus 1 3, 3 will come over here. Next will the sum of the previous two numbers. 3 plus 2 5, 5 will come over here. Next will be the sum of previous two numbers. 5 plus 3 8, then 8 plus 5 13, and so on. That is what we want to do. Okay, so we have to write a code for this. So basically what is happening is that we will be having the first number as this one, like the 0, the first one number we can say a is equal to 0, b is equal to 1, and we will be having a number n is equal to, let's say 7. So the question is, find the nth Fibonacci number. So basically it is 0th, 1st, 2nd, 3rd, 4th, 5th, 6th number, 7th number. So the answer for this should be equal to 13. If I say give me the 6th Fibonacci number, answer should be 8. That is what we are going to do. And here we know how many times a loop is going to run. We know we need to find the nth number. We will have the value of n because we will input it. Hence, we will use a for loop for this. So we will initialize these two. these two variables. Then we will use a for loop till till it runs till like 7 or whatever, and we then and 5. See, very simple. 3 will it will keep on going on. Okay, so loop over a omelet. Okay, so while count is less than equal to n, what do we need to do? We need to add. We need to basically, the answer in the end is going to lie in the nth Fibonacci number, right? So that will be I. So here, how do we make sure that that happens? We need to add the previous two numbers. That is what we want to do. So basically, I can take a temporary variable of I, because this temporary variable, now previous is actually going to be equal to, when we were doing in the previous example, we were doing this will come over here, B will come to A, means the new A is going to be equal to B. That is what we're going to do over here. Two number stuff. So this is Fibonacci number. It will be 1 plus number, and we will learn more about like the time complexity and everything when we actually do time complexity. Without now, let's say for the next question we say something like there's a number given to you. Let's say number n is equal to 1, 3, 8, 5, 7, 5, 7, 8, 7, 9. This is a number given to you. Okay, and you basically need to find how many times the number 7 is occurring in this number. So the answer should be 3. How do we do this problem? Pause this video and then figure it out, and now we'll look into the solution. Okay, so basically the idea to do this thing is, whenever you get such questions where you actually have to deal with individual digits, you are going to have to check individual digits for obvious reasons, because you are checking individual digits. Now, how can we get individual digits from this? There can be many ways. You can convert this entire data type to a string data type, and then you can iterate upon it. Or you can do something much more simpler. If you take the remainder of n of any number by 10, you are actually going to get the last value. You're getting the last value. Let's check it out. If I say, let's say n is equal to 1389, and if I divide it by 10, so I can say 1389 divided by 10, so I can say 10 into 138 gives me 1380. Remainder is 9. Isn't this same as the last digit? Hence, n modulo 10 is going to give you the last digit. Remainder of that number with 10 will give you the last digit. So here we can do something like, if I try to take a smaller example in order to make things clear. So I can say, let's say n is equal to 1389. Count the number of 3's. This works. Divide by 10. Then I'm going to check. Is for example, remove this 9. How do I do this? I can just say n is equal to n divided by 10. Divided by 1, 3, under 1. Last digit 1 equal to 3. No, it's not. Hint. integer. Okay, since we're storing it in integer, it will be like 0.1, points will be cancelled out, only 0 will be there. While n is greater than 0 is the condition, hence this will terminate and our answer will be available to us. I can say n is equal to n divided by 10. This solution, we can also do some really optimized later on. Logic start. And the drawing part, D2. Pause this video, think about it, and it's going to use the same remainder approach, and the number look into the next problem. Now let's try to do another important question. Let's say you are given a number that is, let's say question that number is given to you that says the number is 23597. The answer should be the reverse of this number. So the answer should be 79532. Pause this video, think about it, and it's going to use the same remainder approach, and then watch the rest of the video to get the answer. Okay, you have the number. Same thing we were doing previously. Make plus 2, which is going to give me 2 come over here now. How do we make sure 9 comes over here? Your answer. Make sure you do. You do again it answer. Idea is I'm going to take the remainder every time while the number is greater than 0. I'm going to take the remainder. I'm going to add it in my answer. So initially, let's say the answer is 0. Okay, and my number, like the entire thing, is over here 23579. When I take the remainder for the very first time, my remainder will be 7. I'll add it to my answer. Answer will become 7. Okay, then I'll take the remainder again. It will now be 9. Before adding, this is the same thing we were doing previously. Only one extra step is needed. When you are adding this number in your answer, make sure you have to basically add the number in your answer so that it should be like 79 over here, right? So basically you need to shift this 7 towards the right, so towards the left. So what you need to do is, you have, let's say, 7 over here. Okay, and you have 9 over here that needs to come over here now. How do we make sure 9 comes over here? We can just basically, can we not do, if I do something like 7 into 10 plus 9, what is this going to give me? 70 plus 9, 79. Let's say I take another number 5 plus, make sense? Remainder 2. 7953 into 10 plus 2, which is 79532. Last remainder then now be 0. Isn't this my answer? Okay, very simple solution. Same remainder, same dividing. Only thing, we are just going to multiply the answer by 10 and add the remainder in order to get the answer at that particular point. When the loop finishes, this will be my entire answer. Let's try to code this program. Okay, so let me create another file. I can say reverse static void main int